Okay, so I just wanted to quickly go over the one-shot pipeline that we have as an example of how LLM Compressor can be used inside OpenShift AI. In this, we just have a few components. These are kind of like the building blocks for our experiment. I'll just go over them pretty quickly here. The first case we have, the simplest case, is just a data-free compression, where we just have the model and the recipe, and we're going to build an output model. You can see here we're using as our base image the LLM Compressor pipeline runtime image. And all we're doing in here is loading up our model and loading up our tokenizer, which is what creates the input IDs to pass into the model. And then we're going to call one shot on that model and then save those values. So this runs fairly quickly. It can even run on CPU. A more advanced case would be a calibrated one shot. And so you can see we're using the same image, and the difference here is that we're going to actually use a data set as well and some other configuration for how we're loading up that data set. So it's very similar. You'll see down below that we're calling one shot. But you can see there's a lot of other code here on how we're going to arrange our data set and pre-process it so that it can be fed into the model during one shot. This is a little bit more advanced. This often requires a GPU, so we'll show this as well and show the value of using a calibrated compression over typically better than data-free. And then lastly, we have our eval model. This is another component. So the output of those two components can be passed into this eval model component, just a downstream part of our pipeline that can evaluate the model against a given data set or a given task. In this case, we're using LLM eval, which is a popular open source package for evaluating language models. Will allow the user to provide the task that they want to run. We'll run GSM 8K, which is like grade school math challenges. You can see here we're actually going to be using VLLM to do this efficiently with the quantized models that we create. So those are the components, and lastly, the pipeline is what composes our experiment from those components. These are all kind of user inputs. We have the model ID, the data set we want to use. In this case, we're going to use Llama 3.2, a fairly recent model for Meta, and then we'll build the pipeline or the experiment from there. Here's our data-free recipe. So we're just going to be using the W4A16 scheme that we discussed in the blog post. That this will quantize all the weights to 4-bit data to decrease the memory and computational requirements of running it. For that, we're going to build that task. These are configurations for setting, what are the resources that we want to use for this. And so this we might need to configure to be higher for a larger model, or if you have more higher resources on your OpenShift AI cluster, you can increase these as well. We do the same thing with eval. One thing to note here is that we're actually adding our GPU here. Similarly for the calibration, here's our recipe. We're going to be using GPT-Q, which is one of the first compression algorithms to kind of come out in research that will also quantize to 4-bit precision. You can see here also adding GPU access on each of these on the eval task as well. So I'll run this real quick. All we're going to do is compile this pipeline into a YAML file that we can upload into OpenShift AI. So let me run that real quick. So I have my one shot now. Let me open up OpenShift AI here. This is the data science pipeline dashboard here. I'm already inside my project. I can import this pipeline. So let me do LLM Compressor, W4A16 experiment. Let me upload that file. And so you can see here we have this is our calibrated run, and here's our data-free run. It is going to cache that output into an object store that we can access later, and then it's going to eval the models. So I can kick off a run here. Let me just call it run 2. We're going to be using that pipeline, and then if we want to change any of the configuration for the input parameters of the pipeline, we can do that here, but I'll stick to using this UltraChat data set and Llama 3.2. So we can create the run. It might take a moment. You can see it's pending, running now. So what this is going to do is when those resources are available, it's going to launch those experiments in a standalone environment using those images. So you can see here that these kind of ran quick. That's because I ran this just a moment ago, and it's able to use the cached results and just kind of provide them here. So just to give you a quick rundown of what's available then, we can see here, this is like to run the calibrated. If we want to get the output model from the calibrated run, we have a URI right here. And then if we want to see the eval results down below, we can see here's the output. Let me do this. So we can see for GSM 8K that we're getting about 60% accuracy on the flexible match and about 58% on the exact. And then if we compare that to the data free flow, we get about 57%. So it's a marginal increase. We're using a small model here, so the compression isn't as valuable as if we were to use a larger model. Just wanted to use it for a simple example here. I compared this. I ran separately that the full floating point 16 model gets about 67%. So it approaches there relative to just using the naive data-free approach. So that should give you an example of kind of the experiments that you can run in a scalable fashion. We could run multiples of these. We can share the results. We can share the model artifacts with other stakeholders from there. Thank you.